Has that overloaded everyone for now? So as you create your PCBs, this will become more and more evident. You know, I see your computers now, you've all got great designs down. You're going to import that to Ultiboard, and what you're going to notice is that Ultiboard's going to complain if it can't find a footprint. So you need to now place the footprints on your schematic. That happens in the schematic.
We've done the footprints, but what we haven't done is kind of the justification behind the footprints.
Okay.
So people are just experimenting with the different sizes at the moment, I think.
So that's what you need to be aware of. So the footprints that you've chosen, think about the actual product you're making. Think about the end size of the PCB. And when I say the end size, does it have any knobs on? Does it have any sockets on? If you've designed a PCB here and it needs a headphone jack, it's no good putting it in the middle, is it? You want a headphone jack on this side. If you've got some variable resistors, you want those on the side, because ultimately, what's going to happen with a PCB? If you sell it to someone, they're not going to hold your PCB in their hand and use it.
Do you want to show them that one? Then?
It's probably going to go into a box or something along that line. It's probably going to go into a plastic box, a metal box, and then you need to surface the inputs and the outputs and the variables for your board in some way that the user can use it. So with this in mind, you're going to get an idea as to how big your end board needs to be. And when you have that in mind, you need to consider all the components that you choose footprints for can fit into that defined area that you've chosen. This was a board that I'd done for 2 or 3 years back for this module. It's an amp board, and as you can see, I have an input that goes in there. I have an output that comes through the other end, so there's a clear signal path here, isn't there? A clear signal path that passes through. I've used surface mount components. Yeah. The variable resistors are volume, tone and bass, and they are on the edge of the board. They can stick through the top of the board, so I can put some knobs on it. We've got a power connector over here, and we've got, and this is the bit that most people miss, we've got some way to fix that board into the box. There's 4 holes. You need to put that on your PCBs as well. How are you going to secure your PCB into its end enclosure is also very important. Okay? Here, many years ago, when I first met Dr. Woods here, I was studying this exact course. And this was my submission for this course. So what we have here may be a little bit more than you would have liked at that point.
Well, I had to mark it, didn't I? That was the trouble.
But it's got a bit of everything. Look, we've got a really fine pitch processor in there. Tiny. What we call that is a QFP. It's a quad package. You've got lots of surface mount stuff going on. Some inductors. You've got some through hole stuff. A couple of motors down there. Programming ports. Everything. And that's a 4-layer PCB. Got some bits going on the bottom as well.
Just tell them what it was, Mike.
It was an energy harvesting chip that had a solar panel on there. And what it did was it harvested energy built up into a supercapacitor. And then once it had enough energy, it spawned a Bluetooth connection that you could connect to your phone and then drive it around and do various things until it ran out of energy. In which case it would happily just stop itself, find a light source, recharge itself, and then give you the connectivity. So it goes to show that this module is actually a really nice module to be on, and it has been for years, and it gives you the freedom to design whatever you want. So I strongly recommend that you grasp that and go for it. So there's another example of what we need to consider in our boards. Okay, so don't forget fixtures, don't forget how the end user is going to use your board, whether they need to plug things in, what kind of box it's going to go into, all these sort of things you need to consider.
And start looking on the web for the source of the material, because that becomes a bigger issue when you become more professional, as it were. So when you find a footprint that you're comfortable with, just do a little web search and see whether you can buy those components. And another thing that Mike didn't mention there is the number that you have to buy. So it's rather difficult to purchase one 0201 10k resistor. You generally have to buy 10,000 of them or whatever. So you've got to look at the economies of scale. So you go to one shop and it'll be 50 quid, but you can go to another shop and buy half as many for 30 quid. It's a bit like doing your grocery shopping, right? You've got to sort of decide what you're going to do with those components in the future and whether you can reuse them and all the rest of it.
Size of board as well. Size of board as well is important. If we want to get a prototype, we can manufacture your PCB. We can take your PCB, send it to somewhere like PCBWay. For $5, they can return a board ready to be populated. But there is a 100mm by 100mm limit. So if you load up Ultiboard and start designing this huge board, and we've seen it many times, that's this big, with components sparsely placed, it's going to cost hundreds of dollars. Really is, yeah? So you need to think about that all the time. If you're going to produce 1,000 boards, you need to get that as small as you possibly can. You might not have the ability to choose a hardware. You might be working with a hardware guy, and the hardware guy's designed a box or an enclosure, and he said it has to fit in this, and here is your outputs and here is your knobs. So you need to define those constraints right from the beginning. All this sort of stuff you need to continually think about, yeah? But the really important thing, every component that you've got in your schematic, you need to choose a footprint for, which means you need to get the data sheet up, yeah? Choose what manufacturer, like a 741 might be, Maxim might make one, Texas Instruments might make one. There might be lots of choices. You need to get those data sheets up, check the availability of that product, choose the package that you want to use that's appropriate for your design, and make sure that you understand that data sheet at that point. Yeah, that's really important.